This lesson is 12-6, probability distributions. The essential question is, how do you determine if a probability distribution is valid? What a probability distribution is usually a chart or a table, but it's all of the probabilities for all of the outcomes for a variable. So it's the probabilities for all of the possible outcomes of a variable. Now, an example that would be pretty simple to think about would be if you were flipping a coin. So if you were flipping a coin, there are only two outcomes that are possible. So my outcome would be heads or tails. And then the probability of each of those outcomes is 1/2. Now you could see that written in a probability distribution as 0.5 because it's pretty common to see decimals in distributions. Okay, our first example. We have a table that shows the results after an algebra test. The teacher records the following grades. Grades range from A to F, and then the number of students that achieved each of those grades. The first question says, what is the probability that a randomly chosen student has a C? So the probability that the student has a C equals. Well, probability of a C would mean that we want to look at how many students received a C, 11, and that's 11 out of how many total students. If we add all of these up, we get 32. So 11 out of 32 received a grade of a C. And I'm going to leave it in fraction form. You could divide it. Remember, when you divide, you would divide on your calculator 11 divided by 32. That would turn it into a decimal, which you could also move over 2 places and turn it into a percent. Next question, in blue. What is the probability that a randomly chosen student has at least a B? At least a B means, at the very least, they have a B. That means that they could also have higher than a B, because at the very least it's a B. So that means we're going to combine the A's and B's for this one. So the probability of at least a B would be 7 plus 9, or 16, out of 32. So that would be 1/2, which as a decimal is 0.5, or percent, 50%. The next example. The owner of a pet store asked customers how many pets they owned. Here are the results. Number of pets, number of customers that responded that way. The question in red, find the probability that a randomly chosen customer has 1 pet. Well, 1 pet, 37 people responded that they had 1 pet. So 37 out of how many total? If we add all of these up, there were 100 customers that were surveyed. So 37 out of 100, as a decimal would be 0.37, or 37%. Next question, in black, find the probability that they have fewer than 3 pets. Fewer than 3. When you see the word fewer than 3 means less than 3. So that means that it is not 3. It is less than 3. So in my table, less than 3 means 0, 1, and 2. If I add those together, I get 73. So 73 out of 100, or 0.73, or 73%. Now, let's go back to talking about a probability distribution and what it is. A probability distribution, if it is valid, there are 2 requirements. One is that the probability of each outcome, each individual outcome, must have a probability between 0 and 1 and it's inclusive. So it could be 0, it could be 1, or anything in between. The second requirement is that the sum of the probabilities of all of the outcomes has to equal 1. So they have to add up to 1 because the decimal for 1 is 100%. So if they're in decimal form, they must equal 1. If they're in percent form, they have to add up to 100%. Otherwise, you don't have all of the possible outcomes for the situation if they don't add up to 100%. Okay, our last example. We have a table that's showing the probability distribution of the number of times a customer orders pizza each month. So X represents the number of pizzas, and then the probability of X is the probability of that amount of pizzas. So 0 pizzas, the decimal is 0.10 or 10%. 1 pizza a month, 12%. 2 pizzas a month, 44%, and so on. Part A, show that the distribution is valid. To be valid, each of those decimal values, so here are the decimal values we're talking about, each one of them has to be between 0 and 1. So, if we look at all of these, are they between 0 and 1? Yes. So they're all good values, all between 0 and 1, inclusive. Then we need to check for the second part to see if they add up to 1. So if I add these, I get 1, 1.0. So, yes, this is a valid probability distribution. It meets both requirements. Now, let's use that distribution. If a customer is chosen at random, what's the probability that they order fewer than 4 pizzas a month? So we see that fewer than word again. Fewer than 4 is going to start with 3 and go down. So fewer than 4 is 0, 1, 2, or 3. If I add all of those together, I am going to get 90%. So probability fewer than 4 pizzas a month is 0.90. Now, last but not least, we have to make a probability histogram or a graph of a probability distribution for this data. So I am going to graph the probability on my y-axis, and I'm going to graph x, which is the number of pizzas, on the x-axis. We have 0, 1, 2, 3, and 4 plus. We are going to go by tenths. Because remember that these decimal values are all between 0 and 1. So going by tenths would make sense. So 0, 1/10 of the people got 0 pizzas. Then a little bit higher than that for 1 pizza. Then we have to go way up to 0.44. So about here. For 3, it's 0.24. So about here. And then 4 plus. Like that. And that's it. There's our histogram. A common probability distribution that you may have seen is called a bell curve. A bell curve, when you're talking about like grading, for example, is when the number of A's and the number of F's are really low, and then the B's and the D's increase a bit, and the C's are up the highest. Like most people are considered average. So you may have seen like a perfect bell curve. This isn't a perfect bell curve. It's the same idea though, that the one in the middle is the highest, and then they fall off on each end. So that's something that you may see in the future if you work with statistics. That's our last example. So your summary and your homework, number 1 through 10.